of observation within the head function. Then the next thing is that there is a str function, which is also a way of accessing your data. Like I mentioned that the way I remember its function is a structure. So it shows you the structure of the data. So you can check, you can apply, here we've applied it to the entire data set that was just imported, but you can apply it to specific variables within the data set. So here we're applying it to height. So this is height. So we took out this height and we applied the str function to height specifically within the data set. Then the next thing is the measures of central tendency. So now the next thing I want to talk about, or that we talked about earlier, is measures of central tendency. And I'll just do a quick summary here. The measures of central tendency that was discussed in class is mean, median, and mode. So the next set of things I will try and talk about very quickly is that there are ways to get mean, median, and mode, and other kinds of summaries where you are just entering the data, right? You're entering the data. Let me see. I mean, you're entering the code rather. So you're saying mean. So like right here, you have mean. The function is mean of the specific data. So you have the data set and the specific variable or column like we did here. Then you can have median of the heights, HT data sets, the same thing essentially, mode as well. So you can write code individually, just single lines of code to try and find median, mean, mode. But there are also, so you can also do other things to give you like the summaries, like there is a table function that once you use that table function, it quickly gives you the summaries of a particular table or data, of a particular data set or variable or column within the data set. You can get proportions. So essentially you can be entering one lines of code to get all of these things. But there are also packages that can help you get all of those things. So one of the packages that we're going to start talking about is Table 1. The Table 1 package just does everything that you are trying to do with all those single lines of codes. It does everything for you with like, it's easier instead of entering like, look at all the things that it gives you here. There's height, height2. It gives you mean, median, the 25th percentile, 75th percentile, minimum value, maximum value, skill, cohort. It gives you all of this with just this line of code. So it gives you the summary of the data set. So for you to get summaries like this, so you don't start entering things individually, you will have to install the Table 1 package, and then you start using the Table 1 package, and it gives you the kind of results that you are looking for. So I'll try and quickly run through how you get mean, median, and mode, and you can be trying that on your computer as I'm going through it, but I'll try to be fast just because of the amount of time we have left. So, and there's one other important point I want to talk about. I'll get to that anyway. So first, the mean. This is how you do mean. If you type this in your console, it will basically just give you the mean of that column. So remember, this is the specific column we're looking at. There are 96 of them. If you open the data set specifically, so there are like 96 different observations. So it gives you, what you've done with that main function is generate the mean of all these values, which is definitely more valuable than calculating it by hand. So it gives you the mean right here. That's 99.73. The next thing is the median. Then if you run the code, it gives you the median. The median is 100. The important thing I talked about earlier that I want to emphasize again is mode. If you do the mode function in R, it does something weird. It gives you, it says numeric, which is not what you are looking for. And the reason this happens is because there is no built-in statistical mode function in R. The mode function in R, what it does is it generates, it gives you the internal, it gives you the internal structure mode, something like that, the mode of the internal structure. Okay, it tells you the internal storage mode of that particular object you are assessing. So for this object height, the storage mode is numeric, but that's not what we're interested in. We're interested in the statistical mode, which is the value with the highest number of observations. That's what we're interested in. So for you to get, if you want to get the mode by hand, like let's say manually without using a package, you have to create a function within R to help you generate that statistical mode. So in this rlab2.rmd document, we have a code chunk between line 70 and line 76. We got a lot of questions about this at the start of the class. And basically, you have to write this code every time you want to generate, you want to create a new statistical mode function. So you could have that code saved somewhere so that you can copy it and use it again. So that would be an option for generating the mode, but you have to enter it all the time, almost like you have to enter the median code all the time when you want to generate the mode, the statistical mode within R. So the way this works is it's a combination of a number of different functions. So there is a unique function, there's a which.max function, there's the tabulate function, there is the match function as well. So all these functions together, writing them this way, eventually generates the statistical mode that we're interested in. So if we run this code now, it creates the function getMode. So the function has been created. So now the next thing is we can now use this getMode function that we've created. It's a user-derived function. So we can use this getMode function that we've created. We can apply it to the same column or variable we've been applying it to since the beginning. The same one we applied median and mean to. So we do getMode for HT height. And when we run that code, it basically gives us the mode, which is 100, instead of numeric, like what we got here at the beginning. So then the other thing you can do within R is you can be entering the output of the functions you are calling into new objects like a variable. So now we can create this object called results and enter the output of this getMode function into results. And then when we do print results, it will essentially give us this 100 that we got at the top. So if we run the code here, we'll see that that's what happens. It generates that 100 that we got at the top. So the next thing we did was we talked about proportions and frequency tables. So to get the counts, so there are in proportions and frequency tables, let me say there are, say like 3 functions that we want to talk about here. There is a table function. There is a prop.table function. And there is a round function. Right? So that is basically, those are the things we will talk about for proportions and frequency tables. So, okay, to The first thing is for the table function, what it basically does is when you use a table function, it gives you like a quick summary of the data set or the column or variable within the data set that you are accessing. So now in this line of code on line 96, what we are going to do is to use the table function, but the output of the table function, we're putting it in this new object, similar to what we did at the top here with results. So we are creating this new object called height table. And then we enter the contents of table into HT height 100. We enter that into height table. And then we can then print, we can then generate, see the contents of height table. So if we do that here, it gives us this result. So we can see 0, 1, 52, 44. This might look like it does not make any sense, but if we think about the structure of the data itself, we'll see what this means. So what this has basically done, the output of this code, what it's basically telling us is, oh, there are two observations, or you can call them headings of this table, and the frequencies of those observations is for 0, you have 0 52 times. For 1, you have 1 44 times. So another way you can try to understand this is go into the data set that you loaded. You can also do that from here, from your environment. Just load that data set. It shows you everything within the data set, right? And remember that the particular column that we are calling is this height 100. That's the particular column we are calling. So height 100. You see that in height 100, you only have two kinds of values. There is 0 and 1. They are all just zeros and 1 throughout the 96 different observations. And that's what the table has done. It has looked at the kind of values. There's either 0 or 1, and it occurs 0 occurs 52 times and 1 occurs 44 times. So that kind of help you understand the output of this table function. The second function is prop.table that you use in obtaining proportions. So if we apply prop.table to this height table, remember height table, we've generated height table from here. This is the output. We put it in this object called height_table. So we can do prop.table into height_table. So this function generates proportions. If we run the code, we see 0.541667 and 0.458333. What is basically happening here is this one, it's giving us a fractional proportion. So for each value, for value 0, what's the fractional proportion of the observation? So basically, it's like saying 52 divided by 52 plus 44, 52 over 96. So if you do that on your calculator, it basically gives you this value. The same thing for this, it's like 44 over 96, and you get this value. The final thing we'll do in this section is obtaining percentages. So if you want to obtain percentages, it's like you're just multiplying what you got here by 100. That's essentially what we are doing. So it's like we're multiplying this proportion by 100. So if you look at the function we're using, we're rounding, there's a round function. So we're basically saying round the result of 100 times the output of prop.table. So this same prop.table code is what we add here, is exactly the same. We're just multiplying whatever that gives us by 100. That's it. If we don't put this, so if we run the code, it gives us, you see it's the same result here, but multiplied by 100. So it gives you 54 and 46. The other thing that's happening is you no longer have this 1667, blah, blah, blah. And the reason why that is happening is because we now have this digits equals 0. This argument, what it does is it tells us the number of decimal places that the result should print out. So this digits equals 0 says, oh, no decimal places. So the results will be 54% and then 46%. So anyways, that's me quickly trying to run through what we did before 5 p.m. And then now we can go to where we stopped before that time. So are there any comments or questions? I know we have like just maybe 13 minutes left. There's going to be another class starting. So we'll have to stop at around 13 minutes. Are there any questions, comments? Can you maybe signify like by just that you understood what I've said? I'm hoping the feedback helps me know if I'm doing something wrong or if there's something I should explain better. Anyways, this next section, we're going to need someone to volunteer to share their screen. This is the part where we start using the table 1 package and we're doing different summaries. Who wants to share their screen? Are we getting tired? Anyway, it's almost 2 hours, so I can imagine. I understand. Okay, great. Thank you, Mahmouda. Okay, so I will just start. I will continue talking about the table 1 and generating multiple quantitative summaries until about 11:58, 59. So the next people that want to use the Zoom can go ahead with using the Zoom. So for table 1, to start using table 1, the first thing we want to do, like we learned in the last hour lab, is just to do library table 1. You can also check within packages. You can just type in table 1 and check if you already have table 1. So like I already have table 1 and it's already loaded. That's why it's ticked. So that's what's happening here. That's why I can use table 1. But you'll have to do that within your own R package or within your R studio. So you can try the library. I mean, you can try running this code. Yes, another thing I wanted to mention is when you open rlab2.rmd, if you don't have table 1 installed, it actually gives you an alert somewhere around this top to say that, hey, one of the packages you need to run the code in this document is currently not installed. So you can just click the prompt to go ahead and install at the top when you just open rlab2.rmd. The next thing is, anyway, so we define variables. For instance, now, when We're trying to get summaries of not just height, but also height too. Remember, when we look at this data set that we're looking at, we have height too. So we're trying to get summaries of height and height too. So in this code chunk between line 116 and line 121, you have height and height too. So you're basically creating a vector here with two components, height variable from your data set and height two variable from your data set. And then you create, so this is one of the objects you've created, VARS. This is another object that you create, tab1. So you can call this a different name as well. You can name it whatever you want, but there is this function that you use with table one, with the table one package. It's called create table one. So create table one has different arguments. These are the arguments within create table one. Anyway, these are the arguments between create table one. One of them is VARS. That's an argument. Interestingly, what we will enter, the value we will enter is this object that we've created here. So we'll have VARS here. And then there is starter, we leave that as blank. So what starter basically does is it talks about stratifying the variable. And then there is data, the data set we're using or that we're pulling these things from. And that's HT. We created that in the beginning already. And then there's include NA, which will be false. We'll set that to false. Once we've done that, we can just do summary of tab one, which is this new object. And when we run that, it gives us the summaries of height and height two. I think this is where we'll stop here. But basically by running this code, it just gives you a summary of height and height two. So for instance, it tells you the number of observations for height and for height two, which is 96 and 96 as we expect. It tells you the mean for height, the mean for 96. So that's why I was saying earlier that instead of entering mean and median by yourself, like with a single line of code, these code chunks generate all those quantitative summaries for you. So you have mean, you have the standard deviation, the median, 25th percentile, 27th percentile, minimum value, maximum value, skew, and cut. So these are all the quantitative summaries for these data sets. It doesn't give you mode anyways, but this is more than valuable. Being able to generate this with just by running this single code chunk can be very valuable. And table one is very popular, and that's basically what happens here. So are there any quick questions? I think we can spend like 3 minutes before the next class starts. So are there any questions that anybody has so far from what we've done? All right, Otunaya, you have a question. Please go ahead.
First, what's the difference between this miss and miss?
What's the difference between this and what?
Miss and miss. This last.
Okay, so I actually don't know this miss and miss. I think maybe it might be missing data, but Dr. Abiri, do you know what that is? Miss and miss. For the output returned by table one. Because it says 0, I assume it's missing data, something regarding missing data. But I'm not sure about that. That's something we can Google and figure out what it actually means.
Okay, sir. Thank you.
Okay. All right, if there are no other questions, I think that's it for me. Thank you, everyone.